So we'd like to just work with this BST, which is the binary search tree class that we have here, and this is the class that we were using. Let me just close others, and so I can just focus on just those ones. We don't need these for now, even this one. So this is the class. This is the binary search tree. This one, this BST printer, this is the one that displays the tree. The one that gives us this thing, which is nice if you'd like to have a look at it. It's kind of interesting though, but it only works with the tree of int. So if you try to make it work with any other things, it's not going to work. Why? Because, well, basically for the distance that they try to keep between the different nodes. So if now you display more something that have a different number of the size of the thing that you print is different, then it's not going to be looking as neat as this. It just looks probably, even the numbers, they're assuming that the numbers are just small numbers. If you use big numbers, you're going to be probably not as neat. So so this is that one. This linked list queue, okay, that is probably where this is going to be used. There's something in NetBeans that you can use. For example, this class, I would like to know where this class is being used. I just right click on it, and there's this find usages. If I click on that, this will tell me where this class is going to be used, and let's click on find. Well, it tells me, okay, this is used, this linked list queue is used in the BST, and it's used here, basically when we do the breadth first, because it was just using the queue to traverse it in breadth first, and that's why we have that here. That's the only way that we have it. No, we have also an iterator here that uses the queue. So it just queues everything, and then that's what this does. So that's what this LLQ is used for. Okay, fine. Now let's just focus on this BST now. So this is the iterator, and this is the iterator. This is the node, and notice the node has to have this extends the comparable. And now what we'd like to do is we'd like to add more things. Okay, this is not needed anymore. I would like to add this isLeaf, this new method that is going to tell us if a node is a leaf or not. So to do that, well, how can I know that it's a leaf or not? I need to search for it first, and then when I find it, I will just check if the left and right are both of them null. Then this is a leaf. So I don't have to start from scratch, because I have something that search for an element here. Now if you're searching for an element, I can have something that looks for it, and once it finds it, it just returns it. But it returns the key. But I don't want the key, I would like the whole node to be able to check. So basically my isLeaf should look like searching, but then after I search it, I just don't want just to return the key, but to return the whole node, so I can ask about it. So let me just do something like this. Let me start here. So I'm going to ask if it's a leaf, but again this is going to return something, and I would like to also, basically I'm going to do the same thing that what I'm doing, something like this, but obviously with the same idea, that I'm going to start from the root, and then I'm going to return if it's, I'm going to do something similar, because if you note the note here, each method needs to call a protected recursive overloaded version that takes the starting node as a parameter. Same thing like this does. So the starting node basically for us is going to be the root, but now this is going to be something different. So what I'm trying to say is I'm going to do something like this, that is using the p and starting from the root. So I'm going to start from the root and try to see if this is a leaf. Is this actually how this works? Not really. So I just need to check that this is going to be a leaf or not. But first of all, I need to find it. That's the first thing that I need to do.
Why do you need to find it?
Because if you give me, oh, you're right, why should I find it? Because I'm giving you I have this, I have the node already. Why would I find it? So yeah, true. I was actually I was doing this for, I would do something like, I was thinking that this is what we need to do.
Yeah, then we're gonna need to find it.
So that's why I was, in my mind, that's what we needed to do, but actually we don't. That's even much simpler. We just need to return something. Return what? If, oh, well, let me just do it in the way that you probably know more. I need to have an if, else. If what? If the p dot left is null and the p dot right is equal to null, then return true, else return false. Which basically what I can do is just this, return this thing. If this is true, it returns true. If this is false, it returns false. So it looks at this. What is the result of this? True? Okay, so we return true. What is the result of this? False? Okay, so return false. And this is much simpler than try to type whatever. But now, just as an idea, what if we'd like to look for, like if you give me a value, I'm going to tell you if it's a leaf or not, instead of like the node. If I have a node, that's much easy, just do this. But what if it was not like this, but this time like the element? For consistency, I'm going to just use EL. However, I prefer use element. Now we need to find it. So how to find it? We need to do something similar than the search. However, the search, I don't want to return only the value. I would like to return the whole node.
Actually, you can use the search and fix the value and compare it to it.
And then when I find the value, how can I know if it's the leaf or not? I can just use what I can do is do something, and then I can say, okay, search for that same element, and if I find it, if this t dot equals, sorry, the element dot equals this search of that element, that means they are equal. This search returns t, which is an element, right? So that's why I'm able to compare them. So if they are equal, then I'm going to return what? That is a leaf? No, I don't know. Just find that they're equal. So I just need to do something else. I need to search basically, but search and not return t, return the node itself. Yeah. Yeah, return the node, return the p. So now, in order for me to do that, I need to do something like this.
Just overload it.
But there's a problem. If I overload it with now returning something like this, that's not overloading, because the overloading does not, the signature does not include the return type. So instead of doing return key, I'm just going to return p, for example. Now I have two options. The first option is to modify the search to make it either return the key or return the whole node. No, the key is the element. Or I'm just going to change the name of the search. I'm going to call it search node, for example. Now, by doing search node, now I need to call it like this. And now I'm then doing the same thing, but this time with searching for a node. And what I'm going to do is that this is this. If I'm searching for an element, no, not this one. I'm just going to put it here. If I'm looking if it's a leaf, the first thing is I'm going to search node about this element starting from the root, and then once I found it, I need to put it into some kind of, let's say, temp or the node, whatever. Let's call it node. So I find this. If I find it, I need to compare then the left and right. So the first thing is, but I need to check, maybe I don't find it. Maybe it doesn't exist. So if it doesn't exist, this should give me, this should return null.
If not equal null.
So I'm going to need to ask if node is not equal to null, and if the node dot left is,
You can use that as leaf.
well, I can use the is leaf, the one with the element. That's true. I can just, for example, do something like this. If it's this one is not null, then I'm going to return is leaf with the one with the element, but this time with element dot the key. Sorry, the node dot the key. Why does it not help me? Okay. What am I doing here? So, what was the suggestion? This is just calling the same thing here. So why would I do that?
We want to call the method that above.
The one above with just the node.
Yeah.
So this is not calling this one. If I just did this, now I'm calling the same. But that's not what I want. So now this is just going to return, if it's a leaf, then it's just going to be true. But what if it's not null here? What if, so if this is not null, I'm going to do the verification. What if it's null? If it's null, it's not a leaf anyways. So it should return false. So if it's not null, that means it's a node. I need to check if it's a leaf or not, and I'm doing that by just checking it. The left and right should not be null, should be null. And if alaikum salam, and if it's null, well, there is no need to check anything because, well, it's not a leaf. It's null. When I call it, I need only one method. What do you mean?
Maybe if you need to check the false will be in sleeve with the parameter element, it will not be false.
You're talking about here, for example, right?
Yes.
So let's say I'm going just to put another case. Case 11. What is case 11? Is same thing like search, which is this is the one. I'm just going to do something like this. Enter the element to check if it is a leaf. Then I read something. Then I'm not going to search. What I need to do is basically just I'm just going to use is leaf, right? That's much better. I'm just going to say is the leaf, the one that has the T, and then this is going to be either true or false, and I'm going to say if it's true, the element, the target, is a leaf. And here, sorry, the element is not a leaf. So now this is what happens if I'm going to just make not 11 to be quit, but now it's 12 should be, 11 should be is leaf, is an element a leaf. And I just need to not forget to put my option to be 12. This is the quit. Now is this what you were referring to? Now if the user gives me a number, let's say 5, I'm just going to check this with 5, which is, I'm going to call this element 5. Now this element 5 is going to search for the node 5 starting from the root, and it will just give it to me into this node. Once I have the node, I'm just going to see, did I find it? Or if it was not null, that means there was a node. I'm going to ask if it's a leaf. If it's a leaf, this one that takes like a node here. Once I have the one that takes a node, I'm just going to ask, is the left null and the right null? If yes, I'm going to return true. If no, I'm going to return false. So this is what happens if actually we find it. But what happens if we don't find it is that this is going to return null, because we will not find it. So this is going to be where we're going to stop. And then this is null, which means this is going to be false. I'm going to return false. So I'm going to see, sorry, the element is not a leaf. Actually, the element doesn't exist, but for us, we just return leaf or not leaf. So that's the idea. Is that okay? To do what? That says if it's null, something like that.
No, it's not exist.
Well, yeah, if it's null. So how can we do that? Well, we can do that, but we cannot use this boolean like the primitive data type.
Yeah.
We can use the boolean, the class data type, because the class data type, this can be null, which means I can return this to be null. So for example, if node is not null, I do this. If that, I'm going to return null, for example. Now what happens here is that this can be null now, which means the boolean can be null. And if I'm here, now I can just say if the target, well, now I have to ask a question because this can be null now. So if this going to be this leaf going to be a boolean, like a class data type. So what I'm going to do, I'm going to have a boolean, let's say result, and I'm going to put this into it. And then I'm going to say if result is null, I'm going to say so the element doesn't exist, something like that, where like the element was not found. And what is this? Variable result is already declared. Okay, so result 2. How about that? So if result 2 is null, I'm going just to display this. Sorry, the element was not found. Else if, now I know it's not null, I'm going to say else if result 2, then the element is a leaf. So if this is true, that means, if I do like this, that means it's true. If it's true, I'm just going to display it's a leaf. Else, that means it's going to be false, so it's not a leaf. So now, sorry, the element was not found, a leaf, or not a leaf, and I can only do that if instead of the boolean, the class, I mean the primitive data type, I'm using the class data type, because now I can return null. If I just move it back to a primitive data type, this is not going to work. And is that okay? Okay, let's count. Now returns the number of non-empty nodes in the tree. Now similarly, we need to traverse the tree now. So how did you do that? I can use the for each. Okay. Use the index. What do you mean? The traversal or breadth first, you mean?
Yeah.
Breadth first. Okay. You could use this to do what? To count?
Yeah.
And then you put like some kind of a counter?
Yeah.
Yeah, yes, you can do that. And let's just do some count, different type of counts. Okay. This is maybe the easiest because there's no recursion that is needed. You just make it a loop and you count. You don't have to think about the recursion, how it works and everything. Okay, let's do that, and then we'll do another version. So let's say, okay, I'm just going to copy, and then how can I do that? By just, I basically need the whole thing.
Yes.
But then I just need another variable that is going to be my counter. I start from 0, and then
Instead of visits,
every time, well, this visit, what does the visit do? It just is the one that prints. So I'm just going to, where's the breadth first again? Here. Instead of the visit here,
just count +1.
you increment, and that's it. At the end, you return a counter. So that's one way. Okay, that's the easiest way basically that you could have done. But what if we'd like to do something with recursion? We could use one of the
Easier.
which one? Is it easier? Okay, so public int get count. So how do you do that? You have to have another get count that starts from the root, and this one is going just to be protected, or it could be even private, and then this one will take a node, right? And then
call the method 2 times.
which method?
It counts with p dot left and p dot right.
So okay, p dot left,
And p dot then without return.
oh what, how?
Yes.
So you just look this
Count with the yes.
another time with hold on, another time with the right,
And before that we have the count.
and before that we have the counter. What do you mean?
Count plus plus.
Where do we put that?
Before the count. Before the yes.
Before this?
Yes.
Count plus plus? What is count?
We have to declare it.
Where? Like here?
Yes.
Int count plus
No.
count is equal to 0,
Yes.
and then
No, it's
count plus plus?
every time it's gonna go to 0, 1, 0, 1, 0, 1.
Yeah.
Because every time now you're going to call this, it's going to initialize a new count, and it's going to increment it to 1, and then go to the left, and then new count. So it's not going to accumulate the different counts. Did it work? Did you try it and it worked? With if else? No. Well, somebody else wanted to say something?
Yes, we have to put it outside.
We have to put it outside. There's one way. You can put it here, for example, and you can send it.
The count. You have to put it outside.
The count you have to put it outside. Outside where?
The
Oh, like some kind of the class, and then each one of them is going to call. Well, yeah, that's possible. Yeah, but let me show you maybe some other things. Now, what you can do is that every time when we go to a node, now we need to traverse the whole tree, right? So to traverse the whole tree, we have different ways how to do that already. We have this in order, or pre-order, post-order, or bread first. We just tried this with bread first, and then we counted this. But let's use some of those that have like this, say, like in order. If I'd like to use the in order one, I just need to do the same thing here, but except that instead of visiting,
Count.
I should just increment, right? So my visit would be just
Counter plus 1.
count, do some kind of counter. So what I could do, I could do something similar to this in my get count. What is it? Get count. Okay, this one, and then but I'm not going to do this like that. It's just get count again and get count again. But I need to return something, or if I don't want to return something, maybe I put it void, and then this visit here is where I'm going just to make some kind of my increment. I can do something like this. Void increment, and then you just, we don't need to have a p, we just need to increment. We don't need any parameter, and this is going to have some kind of a counter that I'm going to increment. Of course, I need to declare this count in the class now, and now this is in the class, even though I'm putting it here. I mean, this is now a new instance variable of the class, which is going to cost us some memory, because we're going to be having an extra variable into our class. But that's fine, it's going to work. But that's not what, I mean, we could do. We could just count, basically, by just doing something here. So the easiest way is to go through all the tree. And what I'd like to do is to, every time I go to 1, I'm just going to call this, and then have to return something like I'm not going to visit anyways. I need to go to the left and go to the right. But now, before going to the left to the right, what I'd like to do, I'm in the root, for example. Now, once I'm in the root, actually, I need to count the root, right? So what I'm going to do, I'm going to do this, 1 plus get count now from the root. Because once I'm getting inside the root, I'm going to get to the left. But then once I get to the left, I need to, well, this is now where it's going to get tricky, because I need to return something, and this is not what I expected to work. No, this is not what I intended to do. I want to do something like the things that we have done in the recursion, and where we added like the sum, we kept added the counted, not like the minimum, the counted, but Well, actually, what I'm going to do to make it work easily is, instead of doing like this, and not to make not something like this, I'm just going to have some kind of, this is the counter, and I start from 0 and I put it here inside.
What do you make it from one?
The method was
From one because the math.
What do you mean about 1?
Lost.
the return type for the method, the question was the integer. Now
You're right. This one, this should return. Okay. Hold on. This should be returning something. So this is fine. I can just keep it like this, and then I would like to then do some calculation and then return this counter.
Why would we start from 1?
What do we do? What?
The counter. Start from 1.
Start from 1.
Yeah. Because the first is the root we can skip.
The first. Okay. So then we send this counter to be like this, and then here I'm just going to send the counter, and then every time I'm going int, and this counter I'm going to put it here. But how does this work? Well, yeah, but when I'm done, this +1, what is going to happen to it is that the last call, for example, this count starts with counter to be 1. I put 1. I call this get count. I get inside. I'm going to call now this root from the left, and then counter +1, right? This is what you said. I'm just going to make it +1. Fine. So now I'm going to call this get count with the left, and then counter is going to be 2. But what am I storing this somewhere? I'm just sending this. I'm not doing anything with it. Anytime. I'm not doing anything with it. It's just like I'm sending a parameter that changes. It should be 1, then 2, then 3. But then when I'm done, when I'm leaving here, when I'm finished, this is not going to be the value of the last one, because I made a call with this one would call with 1, and then this one called with 1 called another one with 2, and the call with 2 is going to finish. So I'm going to go back to the call with the 1, and the counter will stay as 1. So this is not going to be helpful anyways. So anyway, as of maybe a better option, the only thing that we could do is maybe another, like instead of like this visit, we have this increment and we have a new instance variable, and then we add it. And I wanted to avoid having this instance variable, but I think that's the only thing that we can do for now without too much complication. So I don't know if I can find it back from here. No? Yeah. Yeah, so something like this. No? Okay, I'm going to stop here. So let's just do something like this. Instead of visit, I'm going to call it increment, and there's no need to send it anything. And this is get count, and well, I'm just going to remove this. This should be count ++, and I need to declare it. Or the other way is that like what you did, and then return count. Now what is going to happen now using this, I'm going to get the get count. This get count is going to do this in order, for example, which is go to the left and increment, but it's going to increment anyways. And then when it's done, it's going to finish, and this variable now will be starting from scratch. The only thing that I need to not forget to do is I need to always initialize in the beginning.
So what is the loop? What is the loop?
This one called this is the
Increment, it's just +1. Then it's will end because it's void.
so it's going to end, and then I'm going to go here to the right. It's like the visit. What I did, the visit, what it does, it just displays, right? So instead of displaying, I just count. So the code is going to go through everything, and then it's going to traverse the tree in order, and then instead of just displaying, I'm just counting, incrementing. Now the only thing that I had to do is to make sure that this has to be 0, because every time I count, if I don't put it back to 0, every time I call it, because this is an instance variable, it will keep the value. So that's why I had to, every time when I call the get count, it's going to initialize, starts from 0, and then it will increment every time it goes through one of those. And another thing is that I should make this private and move it to the top. That's more appropriate. Or another way, instead of doing the whole thing, like what you proposed, is that I can have, since I'm having an instance variable, I can avoid having this get count to call this get count. I can just avoid this and then every time I insert, where is the insert? I increment. Every time I create a new node, just count plus plus. So this is where I insert, right? Because this is where the new node is created. So I'm going just to count as soon as the node is created. And then I need not to forget that every time I delete, well, where's the delete here? Every time I delete, I need to decrement. But how can I know that I have deleted? Because if you give me an element and I don't find it, I'm not going to delete. So I'm not going to put here like count minus minus, because this is not going to help. You have to look at the place where you delete. So for example, this is the key that needs to be deleted. Now I just need to know, is it left or right or whatever. So I need to delete it when I'm here. When I found that this is the key to delete, this is where I should just reduce the count. But that's not what is all about. Well, in this here we were asked to have this get count, so probably we could have used this breadth first. That was the easiest way, because we just enqueue and then count, and or the for each, which that we have already an iterator of, and then we can have like the for each. And let's do that. Like this will be the last one we're going to be doing. Okay, what about this? Now this public int get count. Now if we'd like to get the count, we're using the for each. I can have for each, and then for each what? For each node that we have. In the tree. But where's the tree? Do we have a tree here?
No.
Where is it? This for each can work if we are in the main and we already have a tree, then we can do that. But then, because I need to have a list. Now where is the list going to come from? We have the class, we don't have the list yet. Now here, this for each, if I'm using it here, then yes, I can have now here like a for each somewhere, but because now I have the tree. This is the variable that has, this is the tree that I'm having, this is the tree, the BST tree that I'm having. Now if I'd like to have this for each element from the tree, then I can do something, but I need to basically have this node of integer from the tree, and then of course I need to import this because it's not part of create class. What is that? Because the node is, now the problem, no, it's not about the static. First of all, this tree is not declared in the whole class, it's just in the main. So that's one problem. Well, I can fix it by just put it in here. Okay, fine, now I'm using it in the whole class, but still this creates a problem. Why is it a problem? Non-static variable tree cannot be referenced from a static context, which means I'll make it static. And then now what is this? Everything is okay except this one, because this is an inner class of the bit tree, and this inner class is protected, so you cannot just have access to it. So even so, the for each is not going to be helpful here.
So also he asked for the bit count to put it in the BST.
Yes. Yes. But I'm just trying to, I mean, show the problems when we try to fix it in a different way. How about the leaves counts?
Same.
Same as?
Get count.
Same as get count?
Yes.
Where's get count?
But
We have
but
to check
wait,
the
yeah.
sleeve, then
Okay, so I just lost the get count because I put it on comment. So now, which one is going to be?
first we have to check the sleeve,
And then which method did you use? Like this, or like the one that is going to be like the braid first?
Yeah.
I mean, the easiest is the braid first, probably. But here, if you're using this method, before you count, you should ask.
sleeve.
So how do you know? So you should
There
ask
is
a question. If left and right is
no, yeah.
null, then you have to do something. So you can just put a condition here. If the node dot left is equal to null and dot right is equal to null, then you increment. So now this should be get count leaves, and this just bring it back how it was. This is the get count,
But you also need to
and also need to do something like this.
make it 0.
But then this count here is get count leaves, and we start from 0, and then we get count leaves from the root, and then it's going to do the same thing. But the easiest one is this one, obviously, because you can put a condition here before you even do anything. But I mean, that's why I'm just trying to show you something else. Print non-leaves. Well, basically, instead of
This is
Count
something
one.
count, instead of this increment, it's like the in whatever, in order, or whatever the ones that would like to use, in order, pre-order, post-order. Instead of just visit, you put a condition. You don't visit any of them unless it's a leaf, which is the next is null, and the right is null. You see what I mean?
Get count minus get count.
No, this is not. This is print.
Because he asked how many.
Non-leaves. Oh yes. Then yeah, you're right. This is the. I was talking about this print leaves, which is put the condition if the left is null, the right is null, then you print. Now, if it's the opposite, actually, if it's the else. Yeah. If it's not null in the left and not null on, or not null on the right, then you print. So you just
but that one.
Let's
you
do
can
that.
have issue.
which one?
If you put it to not null left and not null right.
Or
But if you put all
if it's a non-leaf, that means the left is
all
not null or the right is not null.
and it's making
Yes,
mistake.
it's not going to work. Yeah. So, do we need to do it, or is it okay? We can do it. I've seen. Let me just do it with this. Okay, I'm going just to copy this. Basically, let me copy this one first and put it here. Now I'm going to just ask print. Which one do you want to show? Print non-leaves or leaves? Non-leaves.
Non-leaves.
Let's print non-leaves, So print non-leaves is just going to print this unless only if it's a not a leaf. So how can I know if it's not a leaf? It's not a leaf if, now what am I doing? I need an if. If the left is not null,
Or
no,
or
no,
or.
it's or. The right is not null. Because if you put and, that means I want them both to be not null.
Yeah, if one of them is gonna.
I want them both to be not null, which means now you're only printing if, you're only printing this one if it has two children. That's not what I want. If it just has one children, like this one, if the left is not null, well, that's not this. It's null. Or the right is not null. Okay, yes, the right is not null, so I'm going to display this. If you put and, the left is not null and the right is not null, you're only going to display the nodes that have two children, and the one that has one child is not going to be displayed.
But you can do it if you do like make it in the else that you print.
What do you mean else?
Like
This is what I'm doing, okay? Else
F-
what?
No, the F here.
Yeah?
Just continue. If it's both are null, then it just continue. If it's
I don't understand what you're saying.
change it to equal instead of not null.
Equal,
Yeah, and the other one is equal.
okay?
Then, but just instead of visit b, continue.
Continue works with the loop. I mean, this is not a loop, this is a recursion.
It just it does nothing, and make it in the else that's sprint.
Well, you want to do so, well, fine, yeah, I understand your point. What I'm trying to say is,
Yeah, if
hold on.
If you need to use the and, that's what I mean.
If you insist you don't want to do this, you can just, let me, before I forget, just put these back here. You can just make this to be the opposite. If this is the opposite of this true, is then you do nothing, then you put an else. But what's the point? I mean, you can just reverse the condition if you insist of seeing the end for whatever reason. But the main thing is, I mean, what's logic is,
Yeah,
we're going to print if this is not null or this is not null, then we're going to print it. But if both of them are null, then we're not going to print it. What you're trying to say is that, okay, if we do something like this, this means it's a leaf.
yeah, so
And if it's a leaf, we don't do anything. Else,
yeah, we do something.
we print. But this is just, the opposite of this is
Oh,
not equal, and the opposite of and is or, and that's it. And now all I need to do is to copy this, paste it here, so it's just going to be the same idea, and of course I need to call this. A question?
What if both null?
What if what?
Because when we
If both are null,
use or,
if both,
check just one and then
no, not null,
when we use
not null. If they are not null, that means, okay, if we look at this one, okay, is the left not null? Yes. Is the right not null? Yes. So one of them is true, I'm going to display this because it's not a leaf. But like, what about this one now? This 4. Is the left not null? Well, no. Is the right not null? No, so I'm not going to display it. But what about this one? This one that has one of them that is false, the other one is true. So is the one not null? This one, the left, is it not null? No, this is false. But this one is true. It's not null. The right is not null, so yes, I would like to print this one because it's a non-leaf if it has the left or the right or both of them, left and right. I think now much better. So I can basically do that. If I'd like to print the leaves, just copy and paste. Did I paste? Yes. print leaves. So print leaves now means and equal. Now this is what I'm going to print. I'm going to print only if they're equal. Is that okay? So it's now print odd nodes or odd leaves. This is basically the same. Instead of I just have to add another condition before printing, which is let's just add. I can just make it this way. If p dot key, while it's kind of not working all the time, because this has to be a number. Because now if I do something like this,
you have to downcast it.
or put a condition that this extends
Integer,
numbers.
integer.
Number. But it's going to mess up some of the things. Yeah, the one that the iterable thing. So because numbers are comparable. Number is comparable. If I do this, it's even more specific. Yes. If you number, a number is implements. Okay, no, it doesn't. I thought it should be comparable. Okay, so yeah, that's why now we have a problem. But if I'm downcasting it, it might. Okay, let's say print. It might raise an exception. Print non-leaf. Print odd. Where I was looking at print non-leaves or something. Which one? Yeah, here. Now, if I'm downcasting it, it's going just to create maybe some problems, because what if it's not a number? So if I do something like this number or integer equal integer of my p dot key. Now I'm downcasting the t to here, but sometimes this might raise an exception because there's no way to downcast it. But at least we have something that have the idea. So actually, when I did it, I did not pay attention to the fact that it might not be working. Yes.
Why did you just add the integer before?
What did I do? What?
Why do you put integer 10 equal integer then?
This
Yeah.
this one?
Yeah. Why
You wanted just to do this?
Yeah.
Yeah. Well, look at, just for clarity. Yeah.
Okay.
This would be nice.
That's one is wrong.
No, it's okay. We can do that. But it's just more complex. I wanted to explain what I'm saying. Yeah, that's fine. But this is not. This is dangerous. This has to be. You have to check that you can do the downcasting, because there's no way that any t can be converted to an integer, because t now can be a student, but you can't convert a student to an integer, and it's going to raise an exception. So anyways, so I'm just going to backtrack on that, and yeah. So these last two will work only if we have an integer. Yeah. Can do what? Yeah, we are going to stop now and free to go. You seem to be in a hurry.